Alright, welcome back for video 2, where we'll go ahead and have a look at the remainder of what's on this particular sheet, and then we'll have a look at the other one as well. Alright, so simplification. I've done a little bit of treatment of this in the video on the workshop, so I'll let you sort that through. Simplifying these forms. Now we're looking for same families. That's all this is. Okay, same families. So the Y doesn't have any family there with it, so it can't do anything, but all of the others can be put together. So if we've got 6x plus 3x minus 4y, that's how we say it, isn't it? But in your intuition, in your mathsy eye, what you're looking for, okay, is that you're looking for, there's my question mark, and a bit of a hyperbola, and what you're looking for is the same families. So 6 apples plus 3 apples is 9 apples. 9 apples take away 2 apples is 7 apples. And that's the most that we can do. We have to stop there. Okay. For the next one, we've got okay. So what's your mathsy eye see? You know, labouring this as I am. Maybe I'll do the thing that way with a couple of hyperbola. I'm thinking about this function, this math function. So with this particular one, that kind of looks a bit better, doesn't it? I might do it that way. This is -1. Okay, so I'm going to do the whole thing just to be completely annoying, but you know, this is really you understanding that's happening there. We can't do the brackets because they're not like terms. Okay, there's no like terms there, so we can't do the order of operations that require us to do the brackets, so we have to do the expansions, one term then another term, and we're timesing on each occasion there, and so we've just got to be very careful of that. So 2 times b is 2b, 2 times 2y is plus 4y, minus 1 times b is minus b, minus 1b if you like, there it is, minus 1, that's the equivalent, and minus times a minus is a plus, so we'll get 1 times 6, so we'll get plus 6y. Okay, very straightforward. Alright, now when you're doing things like this, you can use technology to help you. Okay, so in this case here, if I've introduced this in a number of occasions now, but if I put in this expansion that I just did, 2 bracket b plus, what am I doing, 2y, close the bracket, minus another bracket, 6b minus 6y. You don't need to do this at this level, I guess, but you can, that's the point. And you want to see how that expands. Mathematica, in its Wolfram Alpha version, will expand for you and show you what it looks like. And, oh, well, it's really needs me to tell it to do an expansion. Okay, so we're going to go simplify. Now was that the one? B plus 2y minus b minus 6y. B plus 10, so let's go back to our, smooth that up a little bit. Okay, so 2b minus b, 2 apples minus an apple is b, and 4 oranges plus 6 oranges is 10 oranges. So b plus 10y, and of course that gave us what we were looking for, wasn't it? Okay, so b plus 10y is the same result. So you can go through. What it doesn't do, of course, is it doesn't give you the steps. Now, if you pay you know, $20 a year and get a subscription, you can get a student education subscription, and in actual fact it'll show you what's happened there. Okay, so if you want to really develop your intuition, that's going to cost money, and I don't normally advocate doing that, but In actual fact, this is the case for every single thing. So if you want to get some observational educational experience, that is a great way to do it. Okay, that is a great way to do it. All right, so so they're just the general rules of expansion there. So we can go through that. Now, of course, you can't use Wolfram Alpha in assessments. You can use it for homework, but I'm not. It can't be used in the labs and the final exam. The expectation is that you wouldn't do it there either. All right, so when we go along and do these other guys, here we go again. Here's another one. 3c minus a bracket minus 2b plus c. So what's your mathy eye looking at? What's your mathy eye looking at? Yeah, I don't know if I like that so much. I still think I might just do my question mark, do my oval, do my circle, hyperbola, hyperbola. So what's your mathy eye seeing? Your mathy eye is seeing minus 1 minus 2b plus c. It's the same thing. They're equivalents. As long as you don't change it, but you draw the meaning out, there's no problem. Now, we can't do any internal bracketing on that. That's contradictory to the rule about order of operations because they're not the same. That only applies where they're the same family. So in this case here, we're going to be expanding these terms like this and multiplying. So we'll get 3c minus 1 times 2b. So minus times a minus is a plus. So we're going to end up with plus 2b. Minus 1 times c is minus c. So 3 carrots minus a carrot is 2 carrots plus 2b. Now, if you wanted to be really pedantic, now that's okay, I'm happy with that, but you need to watch for it because some lecturers like you to do this. Take out the common factor. That's kind of the reverse step, so that's factorising. So that's an expansion. And now a factorisation. And the way that you do that is what's common across the plus minus sign. Okay, that's a very big part of factorisation. What's common across the plus, 2 is, so 2 comes out and then we do a bracket. Parentheses, whatever you want to call it. Okay, so the 2 comes out, then we do a bracket and we leave the sum in. Alright, so there's some examples there. I'll leave you to do the others either by technology or by hand. Okay, whenever we get these guys, these are no really that big a deal either. Just working slightly, using our intuition. What's your mathy eye seeing? Okay, so everything's getting multiplied. Everything's getting multiplied. So the minus times the plus is giving a minus. The 3 times the 4 is giving a 12. And the x5 times the x2. So what's the x5 times the x2 mean? X5, and what do we do with the indices? We add them. X7. Okay, so use your Wolfram to check if you're not sure. So we're going to put it in as 3x5, 3, so you just type in 3x and use the caret symbol to the power 5. There it is. Whoops, I used 6. Didn't press the shift button. Sorry. 3x. Now leave it spaced so that it knows. Then put your bracket and then put the minus 4x squared in. Minus 4x. Use your symbol again, caret. And then what are we looking for? A square. And close up your bracket. Okay. And just check your first line. You can press this thing 100 times, it doesn't matter. So 3x5 tick, minus 4x squared tick. So we got the correct thing. And then you've got your result, minus 12x7. Let's just go and check what we did. Oh, I didn't put it in. See, there's your x7 equals, and I should have put that down, naughty boy. Okay, so there's your answer. So what's your mathy eye doing? Okay, what's your mathy eye doing? Okay, what's your maths eye doing? Your maths eye is seeing what's happening there and saying, oh, I know what to do. So this often happens with this expansion. We'll do another one of those, I think. Let's do, what are we looking at? Minus 2b squared y3. Oh, wow, putting it in brackets. So brackets can be a bit misleading sometimes, but it's just to group them. In this case, they're grouping the info. They're saying, look, those two terms, that term includes the b squared and the y cubed and the minus 2, and this term includes the, that's the only reason for the brackets here. Now we can put that into Wolfram, or we can recognise that everything is being multiplied. Off you go, timesing. So the numbers are being multiplied. The minus times the minus is going to give a plus, so I won't even put that. The numbers, 2 9s are 18, so it's plus 18. Okay, minus times a minus. There's no a. Wait a minute. A times, well, a gets its own little place there. B squared times b. B squared times b. What's your maths eye seeing? It's b squared 1, b, 2 plus 1, b, 3. So we're going to put b3 in. There you go. y3, y5. So what's your maths eye seeing? Okay, so they're already there, so we're going to add them. And so we get y8, y8. You can use Wolfie to help. I don't mind you using Wolfie. I'm encouraging you to use Wolfie to help. Okay, so we'll put that in a bracket, and we'll just call it bracket minus 2b squared to the power 2, or minus 2b squared space y to the power 3, close your bracket, and I think you better put an open bracket in there, and we'll just delete some of that. So minus 2b squared y3, yep, and then minus 9ab y5, minus 9a b, and we'll change that y, and 5. Let's have a look at what that looks like. Whoops, this is a 25 buster. Alright, let's see what the first line says. Just make sure we've entered it correctly. Minus 2b squared y3. Minus 2b squared y3. Tick. Oops. No, not 4. Alright, try again. So that's why we checked that thing, just to check our entry. Minus 9 AB y5. Tick. I think we've got that right. And so then we've got 18 AB cubed y8. And you can do your step by step if you've got the business. Okay, and it's basically just going to do what I did. It's going to take you through the steps, combining like terms, putting them all together, blah 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 blah. Okay, so we get to the same point. So it doesn't really matter how you do it. Okay, A, the order's different. B cubed y8, they're the most important things. B cubed y8. So you know we're at least as good as Wolfram Alpha. Okay, so I encourage you, please. There's no excuses in this course, in this subject, for not conquering all of this algebra. So some of it's quite straightforward. Now, this one here is a bit cheeky. X plus 5 all squared. Okay, that just means x plus 5 twice, doesn't it? X plus 5 twice, and that's a FOIL. That's a FOIL expansion. So FOIL. So we've got first, outside, you may not have seen this, inside, last. Okay, first terms, outside terms, inside terms, last terms. Okay, so first, x squared, x times 5 is 5x, 5 times x is 5x, 5 5s are 25. Okay, so we get x squared, please. 5x, 5 apples plus 5 apples is 10 apples, plus 25. So we'll come back and do some more on that, okay? Alright, the divisions, look, you know what, at the end of the day, the divisions are really easy. You can do the whole thing this way. 4, 5, 6, 7, 8, 9. You can use Wolfram. 1, 2, 3, 4, you can cancel those out until you get to learn 1, 2, 3, 4, 5. Okay, or what we could have done was 4x9 over x4. We could have said 4x9 minus 4, which is 4x5, but you have no excuses. Okay, so you have no excuses for not doing that. Alright, so for these guys here, roots, well, we know what the square root is if they're not putting the nape in. So we can look for this. The first one's going to be 2. 5 5s are 25. Now the cube root of 8 means a number times a number times a number equals 8. There's our 3, you see. There's our 3. What is it? 2 2s are 4, 2s are 8. Trial and error. Try 1. 1 1's a 1, 1's a 1. Nope. 2 2 2's a 4, 4 2's are 8. Tick. Okay, same for this guy here. The cube root, so that means there's 3 numbers that add up to 27. So you try 1. You stop putting pressure on yourself to have the answer. 1. 1 1's a 1, 1's a 1. No. 2 2's a 4, 2's are 8. No, we just did that one. 3 3's a 9. 3 9's a 27. We have a winner. So the answer is 3. Okay, same kind of thing. This time there's 4 numbers that multiply together to give you 16. Try it. Trial and error. Who cares? 1 1's a 1, 1's a 1, 1. Nope. 2 2's a 4, 2's are 8. 2's are 16. We have a winner. Okay. That's exactly what it is. Now you could do your indice form if you wanted to. I mean, you could go 16 to the power of a quarter, and then by recognition you could recognize that 16 is 4 4 or 4 squared. You could do 4 squared. Okay, 4 squared to the power 1 quarter, and so you multiply 2 by a quarter, and what do you get? You get a half. So then you're getting the square root of 4. You can chain it down that way if you want, and the answer's 2. So either way, you can work it out, okay? So I really just encourage you to really just think carefully about these things one step at a time, okay? Now, when we get them like this, we did this before. This is the same as saying, why can't we split? Because it's multiplication. You can't do this with these guys, okay, but you can do it with these guys. So this is the square root of 9 multiplied by the square root of 16. The square root of 9 is 3, and the square root of 16 is 4. So that's 12. Here, the square root of 9 is 3, and the square root of 5. Now 5 is not a number that's got squares in it, so the only one we can do is the 9, which is 3. So we end up with this odd looking thing, 3 root 5. Okay, so that's a skill. It's a skill that takes time to develop. For this one here, the square root of 8, the square root of 8 is what are the products of 8? 4 and 2. So we get the square root of 2 times 4, which is the square root of 2 times the square root of 4. Now the square root of 4 is 2 itself, so we get 2 root 2. Often with these indices and radicals, we get things that we're not familiar with, okay? So 2 root 75 is 2 root 25 times 3, which is 2 root 25 root 3. And this one here becomes 5, so we get 10 root 3. Now you can put them into Wolfram. Put that into Wolfram and see what you get. My point to you is you can explore now. You've got the tools. You've got the tools you can explore. Okay, so you've really got no reason not to do these well. Okay, adding those you'll get 25. The square root of 25 is just 5. Okay, 16 minus 9 is 16, 7, 14, 15, 16. So it's just going to be the square root of 7. You have to leave it because there's no number. This one here is a bit cheeky. Square root of 36 over, we did this kind of thing before, 25. So it's 6 over 5. Okay. that kind of thing. 7 minus 3 is 4. So this is the square root of 9. I've changed it. I've missed a line there. Dot, dot, dot is the square root of 4. And so that's 3 over 2. Look, it was a menagerie, wasn't it? And it's the same thing. So I can leave you to do those. Now, when you're adding them, you can't add them unless they're the same. So you've got to break them down. Now, the square root of 12 is an interesting one because there's a number of different products. But it's the square root of 4 by 3, which is the square root of 4 square root of 3. So 2 root 3. So that's its equivalent. We've already done 75 as 10 root 3 plus 10 root 3. Now what you'll notice is because they're the same families, we can add them together. Okay, so it's like algebra, it's like x's. So that's 2 root 3 plus 10 root 3 is 12 root 3. But you check it, you put it into Wolfram. Okay, so you can check these things when you're on your own. That's the most important part. Okay, so we can do the square root of 12 space plus the square root of 75, and what that'll do is it'll help you understand what you're looking at. Okay. So I've got root 12 and root 75, and that's good. I'm glad that's happened because it means I've got to check what I did, and maybe I made a mistake in the 75. Let's have a look. Let's see where I made a mistake. So 2 root 3 for my 12, that's good. 5 root 3. Now what did I call it? 12 root 3. Oh no, I've doubled it somehow. Alright, so I made a mistake. Alright, good. Thank you, Jason. Now what have I done? The square root of 25 is 5. Let me just take this. Oh, I see the difference. I substituted 10. That's correct. The mistake that I made was that because it was 2 root 75, I just put that in. So that's my mistake. I just was rushing there. So I shouldn't have used 10. Okay, I should have done that sum again because I rushed. You'll do the same thing. Don't laugh at me. You'll do the same thing. Okay, so that's what's happened over here is 25 by 3. Okay, which is 25 and root 3. So we get 5 root 3. So it's half, you see. So 5 root 3 in here. And 5 root 3, that's fine. And okay, what are we doing here? This one. Sorry, my thing's gone off there. So 5 and 2 is 7. Alright, so we're back on track. So this was correct up the top here. 10 root 3 was correct because the 2 was sitting out the front. When I did the 75 over here, I used that result. So it was the wrong result. I should have redid it as I've done here. So this is the point, right? It helps you learn. It helps you realize your mistakes. So I really encourage you to do Wolfram. So same kind of thing here. What happens when we put them in? You can put Wolfram in and make it all come together for you. It can be your slave, your helper. Okay, so we've got 3 8s are 24 or 6 4s are 24. We'll just do it piece by piece. So they've all got products. So we've got 3 and 8. 3 8s are 24. 2 12s. I won't use that. What's the other one? 3 6 4s. 6 and 4. So we'll just think about that. Okay, factors of 54. That's 12 and oh dear, I'm just slowing down a bit, aren't I? So look, you know what? That's just finding products. So you can use Wolfram. I'm going to use technology myself for that one. Okay, because I'm just not seeing it. So we'll go up here. we'll go square root of 24. Very naughty, but that's the way I'm going to do it because I'm just feeling a bit, what have I done? So minus, I don't care, that's fine, 96. Sometimes I've been doing this now for a while, so I'm just a little bit, oh, there we go, just being honest with you. Alright, so now we've got the square root of 54, and let's have a look at that. Okay, so let's have a little look and see what's happened there. Let's see what factors there are. Alright, so for 96 we've got 25 by 2 2s are 4 2s are 8 2s, oh that's 32. 32 by 3. Okay, so I wouldn't have picked that quickly. 32 by 3. Okay, and then it's been split. So one of the root 2's has gone out. Okay, 24, that's 6. Now, what's 54 coming down as? I haven't touched 54 yet. Here it comes. Three threes are 9. 27 by 2. So 27 by 2, I wouldn't have picked that. Okay? 27 by 2. So that's why we need a bit of help. Okay? We need a bit of help because the fact of the matter is sometimes you can struggle to pick out the patterns that come out, and that's just radical. So very interesting. Look, I wouldn't cruel you with a really tough one like that and make it worth a lot of marks. That would be something that we would just perhaps not have so much of a premium on. All right, so look, these kinds of things, I'll wait until we do quadratics before I address that. And basically there's a rhyme and a reason behind that. But we'll get used to the whole nomenclature of monomials and polynomials. Alright, so that pretty much brings us to the end of these. Just pop through and do some examples. Now you've got all the tools, that shouldn't be terribly difficult, and you've got your helper as well. So I'll pile that video out here at the end, and I'll let you work on those now that you've got no excuses.